You have to slow down for a second, because if you rush this part, you miss the entire trick the moon is playing on you. And I don't want you to just hear this, I want you to feel it as if you're actually there, standing on that surface, because that's where the illusion begins. Imagine you're standing on the moon, and I mean really standing there, not as an idea, not as a photograph, but as a physical presence in a place where nothing moves unless you move it, where there is no wind brushing against your suit, no sound bouncing off the ground, no distant hum of anything alive, just a silence so complete that it stops feeling like silence and starts feeling like pressure, like the universe itself is leaning in closer than it should. And above you there is a sky so black that it doesn't look like night on earth, because there is no atmosphere to soften it, no glow, no gradient, just an absolute void scattered with hard, unmoving points of light that don't twinkle, don't flicker, don't behave the way your brain expects them to behave. Now look down at your feet, because this is where it gets deceptive. And I want you to notice how ordinary it seems at first, how harmless, how almost disappointingly simple, because the ground is just gray dust, fine and soft, like powder that hasn't been touched in an unimaginably long time. And every step you take presses into it cleanly, sharply, leaving a footprint that will outlast civilizations, outlast species, outlast almost everything you can think of. And there is something strangely peaceful about that. Something that makes you feel like you're walking on a place that has been waiting quietly, patiently, for someone to arrive. And that's exactly where your intuition betrays you, because you've seen the moon your entire life, haven't you? Hanging there in the sky, night after night, familiar in a way that no other object in space is, close enough that it feels like part of your world rather than something separate from it, something distant, something hostile. And you grew up with stories about it, poems about it, images of astronauts bouncing lightly across its surface, planting flags, driving a little rover, even hitting golf balls into that gray dust as if it were some kind of cosmic playground. And all of that builds a very quiet assumption inside your head that the moon is, in some fundamental way, friendly, not safe, perhaps, but manageable, not welcoming, but understandable. And more importantly, already conquered. We went there. After all, not once, but multiple times, 12 human beings walked on that surface, explored it, worked on it, and then came back home. And when you compress that entire history into a few iconic images, it starts to feel like the story is finished. Like the moon is something we figured out decades ago and simply chose to move past, as if it were a solved problem sitting quietly in the background of human achievement. But here's the part I want you to really pay attention to, because this is where the illusion begins to crack. And it doesn't crack loudly. It doesn't announce itself. It just sits there, subtle and uncomfortable, waiting for you to notice it. They didn't stay. Every single Apollo mission that landed on the moon stayed for days, not weeks, not months, not long enough for the environment to reveal what it does over time, not long enough for small problems to become big ones, not long enough for the surface itself to show how it behaves when you live on it instead of just visiting it. And that difference between visiting and staying is everything, because a place can look completely harmless in the short term, can even seem beautiful, still, and predictable, and yet be fundamentally hostile in ways that only emerge with exposure, with repetition, with time. And the moon is exactly that kind of place. It presents itself to you as quiet, was as stable, as dead, but that stillness, the one you felt the moment you arrived, the one that made it seem peaceful, almost comforting in its emptiness, is not a sign of safety. It is the most convincing lie the moon tells you. And the moment you start believing it is the moment you stop asking the questions that would keep you alive. Now here's the part where I want you to catch yourself in the act. Because what makes the moon so deceptive is not what it is, but how familiar it feels to you. And that familiarity is something your brain quietly translates into safety without ever asking for permission, as if simply seeing something often enough is enough to understand it. And the moon has had a lifetime to build that illusion inside your head. You've been looking at it since you were a child, long before you knew anything about physics, long before you understood what space even is. And it was always there, predictable, cycling through phases with a kind of calm reliability that nothing else in the sky seems to match. Sometimes full and bright, sometimes a thin crescent, sometimes gone entirely, but always returning, always following a pattern that feels almost comforting. And over time, your mind does something subtle but dangerous. It stops treating the moon as a foreign object and starts treating it as part of your environment, something that belongs to the same world you do, just a little farther away. And then we went there, which is where the illusion hardened into something much more convincing. Because once human beings set foot on a place, once we plant a flag, leave footprints, drive across the surface, and come back alive, it changes the psychological category of that place completely. It stops being unknown and starts being visited. And once something is visited, it feels understood, even if that understanding is incredibly shallow. Think about what you've actually seen from those missions, because this matters more than you might realize. You've seen astronauts moving slowly in low gravity, almost playfully, bouncing across the surface like it's easier there, like it's lighter, like the rules are somehow gentler. You've seen them working methodically, setting up experiments, collecting rocks, speaking calmly over the radio. And nothing about those images suggests danger in the way your instincts recognize it. There are no storms, no flames, no visible threats rushing toward them. Just a gray, quiet landscape that seems to sit there passively while humans walk across it, and your brain, being efficient but not always careful, fills in the rest of the story without asking too many questions. It assumes that if something were truly dangerous, it would look dangerous. It would behave in ways that trigger your built-in alarm. It would announce itself, and the moon does none of that. It doesn't roar. It doesn't move in obvious ways. It doesn't give you anything dramatic to react to. And so it slips past your defenses simply by being still. But here's the problem. And I want you to really sit with this, because it's the key to everything that follows. The Apollo missions were not designed to understand the moon as a place to live. They were designed to prove that we could get there, operate briefly, and return, which means everything you've seen is filtered through that objective. Short durations, limited exposure, carefully controlled activities, and then a rapid departure before anything subtle had time to escalate. They stayed just long enough to succeed, and then they left before the environment had a chance to fully reveal itself. So when you think of the moon as safe, what you're really thinking of is a very narrow slice of experience. A few days of carefully managed interaction under conditions where every second was planned, every movement constrained, and every risk minimized by design. and you're unconsciously projecting that limited experience onto a completely different scenario, one where humans would stay for weeks, months, or years, where systems would have to endure, where exposure would accumulate, where small effects would compound into larger ones. And that projection is where the danger lives, because the moon hasn't changed, not in any meaningful way. It's the same world it was during Apollo, but your interpretation of it has been shaped by incomplete information, by images that feel reassuring but are missing everything that didn't have time to happen. And once you start extending the timeline, once you imagine not just visiting, but remaining, the entire picture begins to shift in ways that are easy to overlook, until you force yourself to ask a very simple question that we didn't have to answer back then. What happens if you don't leave? And this is where the moon stops being an idea and starts becoming a problem. Because the first thing the Apollo astronauts brought back with them wasn't just rocks or data or photographs. It was something much smaller, something that didn't look dangerous at all until it refused to behave the way anything on Earth is supposed to behave. And I want you to pay attention here, because this is the moment where the illusion really begins to fall apart. Every single Apollo crew reported the same thing, not as a dramatic discovery, not as some headline moment, but as a persistent annoyance that quickly turned into something far more serious than it had any right to be. And that thing was dust. Just dust. The kind of word your brain automatically downgrades into something trivial, something harmless, something you deal with by brushing it off your clothes and moving on. Except this dust did not come off. It clung. It stuck to everything. Their suits, their gloves, their equipment, their visors. And when they tried to remove it, it didn't fall away the way Earth dust does. It resisted. It held on as if it had no intention of letting go. Now imagine you've just finished a moonwalk. You climb back into the lunar module, and all of that dust comes with you, because there was no real airlock the way we design them today. No proper system to isolate the outside from the inside. So the moment you enter, the dust enters with you. And in the moon's weak gravity, about 1/6 of what you're used to. Those particles don't just drop to the floor and stay there. They float. They drift. They hang in the air like a cloud that refuses to settle, turning the cabin into a kind of slow-moving haze of microscopic debris. And now you're breathing it. Harrison Schmitt, the geologist on Apollo 17, noticed it almost immediately. His eyes started burning. His throat tightened. His sinuses swelled. And he began sneezing uncontrollably, something he later described as lunar hay fever, which sounds almost harmless until you realize this wasn't pollen. This wasn't something your body evolved to deal with. This was a completely alien material interacting with human biology for the first time. And other astronauts reported similar symptoms: sore throats, watery eyes, congestion that lingered long after exposure. And all of them noticed the same strange detail that keeps coming up in their accounts: a sharp, metallic smell, like burnt gunpowder filling the cabin. That smell wasn't just a curiosity, it was a clue. Because on the surface of the moon, there is no atmosphere, no oxygen, no moisture. And that means the soil exists in a kind of chemically suspended state, untouched by the processes that soften and stabilize materials on Earth. And when those particles were brought inside the spacecraft and suddenly exposed to air and humidity, they began to react, not explosively, but actively, forming bonds, interacting with surfaces, with equipment, and with the delicate tissues of the human body. But the real problem, the part that should make you uncomfortable if you think about staying there for any length of time, is not just that the dust is reactive, it's what it actually is at the microscopic level. Because this is not the rounded, weathered dust you're familiar with on Earth, shaped over time by wind and water into smoother forms. This is the result of billions of years of micrometeorite impacts, grinding rock into fragments without any atmosphere to erode their edges. And the result is a powder made of tiny, jagged shards of glass, each grain sharp, irregular, and capable of causing damage on a scale too small for you to see, but large enough for your body to feel. Some of these particles are smaller than a micron, small enough to bypass many of the natural defenses in your respiratory system, small enough to travel deep into the lungs where they can lodge themselves and remain. And unlike ordinary dust, which your body can often clear over time, these particles don't dissolve. They don't break down. They persist. And in the moon's low gravity, they stay suspended longer, increasing the chances that you will inhale them again and again with every breath you take inside an enclosed space. And this is where you have to shift your thinking, because what started as an inconvenience, something that irritated the astronauts for a few days, becomes something entirely different when you extend the timeline, when you imagine not just brief exposure, but continuous presence, weeks turning into months, months into years, with no perfect way to keep that dust out, no simple method to remove it once it's inside, and no guarantee that the effects you saw during Apollo were anywhere near the worst it can do. Because the truth is, we didn't stay long enough to find out. You don't actually decide that the moon is safe in a single moment. And that's what makes the mistake so difficult to notice. Because it doesn't feel like a conclusion you arrived at. It feels like something that has always been true, something that quietly formed in the background while you were busy learning everything else about the world. The moon has been there every night, constant, predictable, cycling through phases with a kind of quiet reliability that nothing else in the sky quite matches. And over time, your brain does what it always does when faced with repetition. It stops questioning and starts accepting. You begin to treat the moon not as a place, but as a presence, something familiar enough that it no longer triggers curiosity in the same way it once did. And that familiarity carries a hidden assumption, because things that feel familiar rarely feel dangerous. And things that are always visible rarely feel unknown. You don't think of the moon the way you think of deep space or distant planets. You don't imagine it as hostile or extreme, because it has never behaved that way from your point of view. It has always just been there. And silent, distant, and strangely comforting in its consistency. And then something happened that reinforced that illusion more than anything else ever could. We went there. Now I want you to pay attention to what that did to your perception. Because the moment human beings set foot on the moon, it stopped being an abstract object and became a location in human history, something that had been visited, documented, experienced directly. And once that happens, your mind shifts categories without asking permission. It moves the moon out of the unknown and into the known, out of the unreachable and into the achievable. And that shift is incredibly powerful. You've seen the footage. You've watched astronauts walk across the surface, not struggling, not fighting for survival in any obvious way, but moving with a kind of controlled calm, almost playfulness in low gravity, hopping lightly, working methodically, speaking clearly over the radio, And nothing in those images triggers the kind of alarm your instincts rely on to recognize danger. There are no storms sweeping across the surface, no violent forces visible in the background, no sense that the environment is actively trying to harm them. Instead, what you see is something that looks manageable, and your brain fills in the rest. It assumes that if something were truly dangerous, it would look dangerous. It would behave in ways that are dramatic, visible, immediate. And because the moon does not do that, it slips into a category that feels controlled, almost domesticated by the fact that humans have already been there and returned. But here's the part where you need to slow down, because this is where the conclusion becomes misleading. The Apollo missions were never designed to answer the question of what it means to live on the moon. They were designed to answer a much narrower question. Can we get there, operate for a short period of time, and come back alive? Everything about those missions reflects that goal. The duration, the equipment, the procedures, all optimized for short exposure, limited risk, and rapid return. They stayed for days, not long enough for the environment to reveal what it does over time, not long enough for small inconveniences to become serious problems, not long enough for cumulative effects to build into something that can no longer be ignored. And that distinction between short-term success and long-term survival is the gap your intuition fails to account for. Because when you think about the moon today, you are not imagining a 3-day visit with tightly controlled conditions. You are imagining something very different. Extended missions, permanent bases, continuous presence, systems that must function not just briefly but indefinitely. And the moment you stretch the timeline, everything you thought you understood begins to change. The moon hasn't changed. Your exposure to it has simply been too brief to show you what matters most. The first real sign that something was wrong did not come as a dramatic warning, and that is exactly why it matters. Because if the moon had announced its danger in a way that was obvious, loud, or immediately life-threatening, we would have treated it very differently from the beginning. But instead it introduced the problem quietly, through something so ordinary that your instincts are almost guaranteed to underestimate it. What the astronauts encountered was not an explosion, not a system failure, but a material so deceptively simple that your brain would normally dismiss it without a second thought. And that material was the dust covering the lunar surface. Now, I want you to be careful here, because the moment you think about dust, your mind automatically substitutes something familiar, the kind you wipe off a table, shake out of your clothes, or sweep away without effort. Something temporary, something manageable, something that exists at the level of inconvenience rather than danger. And that assumption works perfectly well on Earth, where dust particles are shaped over time by wind and water into smoother, more passive form. The moon does not give you that kind of dust. Every Apollo crew encountered it almost immediately. And what they described was not just annoyance, but persistence, a material that refused to behave the way anything on Earth behaves, coating their suits, clinging to their gloves, embedding itself into joints, scratching surfaces, and most importantly, refusing to come off when they tried to remove it. They brushed it, wiped it, shook it, and still it stayed, as if it had no intention of letting go once it made contact. Now follow what happens next, because this is where the situation changes from external to internal. When the astronauts returned to the lunar module after a moonwalk, that dust came with them because there was no effective barrier to keep it outside. No fully isolated airlock system. And the moment it entered the cabin, It stopped behaving like something that simply settles under gravity, because the moon's gravity is weak. About 1/6 of Earth's. Those particles did not fall quickly to the floor. They drifted. They lingered. They remained suspended in the air long enough to become something you could not avoid, something that followed you as you moved, something that turned the interior of the spacecraft into a slow-moving cloud of microscopic fragments. And at that point, you are no longer dealing with surface contamination. You are breathing it. Harrison Schmitt, the geologist on Apollo 17, experienced it almost immediately after re-entering the cabin. His eyes began to burn. His throat tightened. His sinuses reacted. And he started sneezing uncontrollably in what he later described as lunar hay fever, a phrase that sounds almost harmless until you remember that this was not a natural allergen, not something the human body has evolved to tolerate, but a completely foreign material interacting with biological tissue for the first time. Other astronauts reported similar symptoms: irritation, congestion, persistent discomfort that did not disappear as quickly as you might expect. And then there was the smell, a detail that appears again and again in their accounts: sharp, metallic, like burnt gunpowder, something that did not belong in a closed environment and yet filled the cabin once the dust was inside. That smell was not incidental. It was a sign that the material itself was reacting. Because on the lunar surface, there is no atmosphere, no oxygen, no moisture, and the soil exists in a kind of chemically inactive state until it is suddenly exposed to conditions like those inside the spacecraft. Once that exposure happens, the particles begin to interact, bonding, reacting, becoming chemically active in ways that are not immediately visible but are very real. And here's the part that changes everything. Because the danger is not just chemical, it is structural. Lunar dust is not rounded or smooth. It is the result of billions of years of micrometeorite impacts, shattering rock without any atmospheric erosion to soften the edges, which means each grain is a tiny, jagged fragment, sharp at a microscopic level, capable of cutting, scratching, and embedding itself into surfaces and tissues alike. Some of those particles are so small that they can bypass the body's natural defenses, traveling deep into the lungs where they can remain. Not easily expelled, not broken down, just present, accumulating over time. And because the environment inside a habitat on the moon would involve repeated exposure, continuous circulation, and limited ability to completely remove those particles, the problem is not what happens once, but what happens again and again. Apollo gave us only a glimpse of that interaction. A few days of exposure, enough to cause irritation, but not enough to reveal the long-term consequences. And that is the detail that should make you pause. Because what looked like a minor inconvenience during short missions begins to look very different when you extend the timeline. Dust in this environment is not just a background detail of the landscape. It is the first clear warning that the moon does not behave in ways your instincts are prepared for. If lunar dust were only sharp, chemically reactive, and difficult to remove, that would already be enough to turn it into a serious engineering and medical problem. But the moon does not stop there, because the material covering its surface does not simply sit still and wait for you to disturb it. Instead, it responds to the environment in ways that are completely unfamiliar. If all your intuition comes from Earth, I want you to return to that image of the gray surface, the one that looked so calm and unmoving when you first imagined standing there. And now I want you to consider what happens when that surface is exposed to direct sunlight without any atmosphere to filter or soften the radiation. Because the ultraviolet light from the sun is intense enough to knock electrons off the atoms in the soil, leaving the ground with a net positive electrical charge that you cannot see or feel. But that changes everything about how those particles behave. Now take the smallest grains of dust, the ones so fine that they are already close to invisible, and imagine them acquiring enough electrical charge that the forces acting on them are no longer dominated by gravity alone. Because at that scale, electrostatic forces can become significant. And when that happens, something that seems impossible at first begins to occur. The particles can lift themselves away from the surface. This does not happen in a dramatic or explosive way. There is no visible storm or sudden movement that would immediately alert you. Instead, it happens slowly, quietly, with particles rising just enough to hover above the ground, suspended in a delicate balance between weak lunar gravity and the electrical forces pushing them upward, creating a thin, ever-changing layer of floating material that surrounds the surface like an invisible haze. And if that were the only effect, it would already complicate any attempt to keep dust out of sensitive systems. But the situation becomes even more complex when you move across different regions of the moon, particularly the boundary between light and shadow. Because the electrical conditions are not uniform across the surface, on the sunlit side, electrons are stripped away, leaving the ground positively charged, while on the shadowed side, electrons from the solar wind accumulate, giving the surface a negative charge, and at the boundary between these regions, strong horizontal electric fields can develop. Those fields do not simply hold particles in place. They can move them, pushing dust sideways across the surface in a way that resembles a storm, even though there is no air, no wind, and no conventional weather system involved. Just invisible forces acting on particles that are small enough to respond to them, carrying sharp, reactive grains across equipment, across structures, across anything exposed to the environment. So now the dust is no longer just something that gets tracked inside by human activity. It becomes something that can reach surfaces on its own. Something that can settle in places you assumed were protected. Something that can continuously redistribute itself without any direct interaction. And once it reaches those surfaces, all of its original properties remain. The sharp edges, the chemical reactivity, the ability to cling, the ability to damage materials over time. What makes this particularly difficult to deal with is that none of it is obvious in the way your instincts are trained to detect danger. There are no visible clouds forming on the horizon, no winds you can feel, no sound to warn you that particles are moving, just a continuous, almost imperceptible redistribution of material that slowly coats, scratches, and interferes with anything exposed long enough. And when you put all of this together, the picture changes again in a way that is easy to underestimate. Because what looked like a passive layer of dust becomes an active system, one that is constantly being energized by sunlight, constantly shifting in response to electrical conditions, and constantly interacting with whatever you place on the surface. So the ground you thought was stable is not truly at rest, and the dust you thought you could manage is not truly contained. And once you begin to see it that way, the moon stops looking like a place where problems stay, where you leave them, and starts looking like a place where even the surface itself refuses to remain still. By the time you reach this point, you might still be thinking that all of these problems, the dust, the chemistry, the strange behavior of the surface, are difficult but ultimately solvable with better engineering, better materials, better planning. And in many ways that is true, because human beings are very good at building systems that compensate for hostile environments. But there is one category of danger on the moon that does not yield easily to that approach. And it forces you to confront a much more uncomfortable reality about what it means to survive there. The moon does not protect you from space. On Earth, you are living inside layers of shielding that you rarely think about. The atmosphere above you absorbing high-energy radiation, the magnetic field surrounding the planet deflecting charged particles that would otherwise reach the surface. And because those protections are always present, your body has evolved under conditions where the most dangerous forms of radiation are largely invisible to your daily experience. You do not feel them. You do not see them. And most of the time, you do not need to think about them at all. Now, remove all of that. On the moon, there is no atmosphere to absorb incoming radiation and no global magnetic field to deflect it, which means you are directly exposed to the space environment in a way that human biology was never designed to handle. And the most significant contributors to that environment are galactic cosmic rays, high-energy particles that originate from events like supernova explosions and travel across the galaxy at nearly the speed of light. These are not gentle forms of radiation that can be easily blocked or ignored. They are atomic nuclei, stripped of their electrons, moving with enormous energy, capable of passing through spacecraft walls, through protective layers, and through human tissue with very little resistance. And as they pass through, they interact with the atoms in your body in ways that can break DNA strands, damage cells, and increase the long-term risk of cancer and other serious conditions. At this point, you might think the solution is straightforward. You simply add more shielding, thicker walls, then some materials, something to absorb or stop these particles before they reach you. And that is where the problem becomes more complicated than your intuition expects. Because when high-energy cosmic rays collide with thick shielding, they do not simply stop. They fragment. Instead of being absorbed, they can shatter the atoms in the shielding material itself, producing a cascade of secondary radiation, neutrons, gamma rays, and other energetic particles that scatter in multiple directions inside the habitat, meaning that in some cases, adding more shielding can actually increase the complexity of the radiation environment rather than eliminate it. So now you are faced with a situation where the obvious solution is not entirely effective, and the environment you are trying to defend against is both invisible and persistent, delivering a continuous background dose of radiation every second you remain on the surface. And on top of that constant exposure, there is another layer of risk that is far less predictable and far more dangerous in the short term. Solar particle events, sudden eruptions from the sun, can flood space with high-energy protons in a matter of hours, dramatically increasing radiation levels in ways that are difficult to anticipate with enough time to fully respond on Earth and even in low Earth orbit. Astronauts still benefit from partial protection provided by the planet's magnetic field. But on the moon, there is no such buffer. And during a sufficiently strong solar event, an unprotected astronaut could receive a potentially lethal dose of radiation in less than a day. The Apollo missions were fortunate in this regard because they occurred during relatively quiet periods of solar activity. But that luck is not something you can rely on for long-duration missions or permanent habitation, where exposure is not measured in days but in months or years. So what you are left with is not just a technical challenge, but a fundamental limitation, because survival on the moon is not only about building structures that can withstand the environment. It is about managing an invisible, penetrating form of energy that does not stop at the surface of your habitat, that does not respect simple barriers, and that accumulates its effects over time in ways that are difficult to reverse. And when you combine that with everything you have already seen, the dust that infiltrates the surface that refuses to stay still, the environment that does not behave the way you expect, the picture becomes harder to simplify, because now you are not just dealing with isolated hazards. You are dealing with a world where even standing still, doing nothing, simply existing on the surface, exposes you to a constant stream of damage that cannot be completely avoided. That is what makes survival on the moon such a difficult problem to solve. Not because any single danger is impossible to address, but because all of them exist at once. And radiation is the one that never gives you a moment of relief. By now, you can probably feel the shift that has taken place, not just in the facts you've heard, but in the way the moon exists in your mind. Because what started as something familiar and almost comforting has slowly transformed into something much harder to categorize, something that no longer fits neatly into the idea of a quiet, conquered world waiting for us to return. And I want you to pause here for a moment and look back at how that change happened, because nothing we talked about was hidden. Nothing was newly invented. All of it was always true. And yet the picture only becomes clear when you force yourself to connect all of these pieces together instead of looking at them in isolation. The dust is not just dust. It is a field of microscopic glass shards that cling, cut, react, and infiltrate every system you build. The surface is not just ground. It is electrically active, constantly lifting and redistributing those particles in ways that you cannot easily control or predict. The environment is not just empty space. It is filled with radiation that passes through your body continuously, damaging it in ways you cannot feel until long after the exposure has already occurred. The temperature is not simply hot or cold. It is an endless cycle of extremes that forces every material to expand, contract, and eventually fail. The moon itself is not a static object. It is shrinking, cracking, and releasing energy through quakes that can last far longer than anything you are used to experiencing on Earth. And above all of that, there is no atmosphere, no buffer, no protective layer between you and any of these forces. Nothing to soften them, nothing to slow them down, nothing to give you a margin for error. When you put all of that together, what you are looking at is not a collection of separate hazards, but a system where every problem interacts with every other problem, where dust interferes with seals already stressed by temperature, where radiation affects materials already weakened by thermal cycling, where structural integrity is challenged not only by engineering limits, but by the slow, persistent movement of the ground beneath it. And this is where the distinction we touched on earlier becomes impossible to ignore, because everything we have ever done on the moon falls into a very narrow category. We went there 6 times. We stayed for a few days at a time. We operated within carefully planned limits, and then we left before the environment had time to fully assert itself. We experienced the surface in fragments, short exposures, controlled interactions. And from those fragments, we built a story that feels complete, but is, in reality, only the beginning. Living there is a different question entirely, because the moment you extend your presence beyond those brief missions, the moon stops being something you pass through and becomes something you must endure. And endurance is where all of these factors begin to compound. Time turns minor irritations into persistent problems, turns manageable risks into unavoidable conditions, turns isolated events into patterns that must be accounted for again and again. So the real moon is not the one you see from Earth, and it is not even the one you remember from Apollo footage, because both of those versions are incomplete, shaped by distance or by duration. And what remains when you remove those limitations is something far less forgiving. It is a world wrapped in razor-sharp dust that refuses to stay where you leave it. A world where invisible radiation passes through you every second you remain exposed. A world that swings between extremes of heat and cold with no transition. And a world that is still, even now, changing beneath its own surface. And that is the part that matters most, because it forces you to rethink what it means to say that we have been there. Because going to a place and understanding a place are not the same thing. And in the case of the moon, we have only done the first. Returning is not the challenge. Staying is